Hi, my name is Sakura. I'm a rising junior at the Brewery School. And for my starter project at Bluestamp, I built a mini POV from the Adafruit kit. What POV stands for is a persistence of vision device. And essentially what I created is a circuit board that allows LEDs to light up in a given sequence so that when waved through the air, when the device is waved through the air, you can see a custom message or image. In order to build this project, I learned how to solder on my first day so that I could attach all of the components onto my circuit board. All these parts included my microcontroller, LEDs, some resistors, Zener diodes, and a serial connector, as well as battery wires coming from the battery holder to supply voltage. And the voltage incoming from the battery case has a total of 3 volts, given that they're two 1.5 volt batteries. And in order to light up the LEDs function best under 0.2 amps. And after exceeding that amount, it's possible to damage those LEDs. So it's important to limit the current that's driving the LEDs. And we do this by implementing resistors. The resistors act to limit the current going to the LEDs. We also have Zener diodes, which also act as voltage regulators to prevent the device from overpowering the circuit board. What the Zener diodes do is allow the current to move in the forward direction by default, but when the voltage increases to a certain level, known as the breakdown voltage point, it'll actually send the current backwards and prevent the device from overpowering. This is important because sometimes there are momentary voltage pulses coming from the batteries, so in case of this, the Zener diodes are important in preventing too much voltage from entering into the circuit and damaging the LEDs possibly. Finally, we have the microcontroller, which is essentially a chip with a program installed onto its flash memory, and the software aspect of my project involved reprogramming the code on that chip so that the LEDs display in a custom sequence to display a certain message or image. And I did this by establishing a serial port connection to my computer on which I installed microcontroller programming software called AVRDude, and I had to solder on a serial adapter onto my device and then use a serial to USB adapter between this and my computer, and use terminal on my computer to run the program, recode it and then run the program. And now that the program, which I customize, is on my microcontroller, I can turn on the switch which will supply voltage to my circuit and allow the LEDs to light up. Now I'm going to demo my project.